All right, so this is 8.3, applying equations, and basically what it involves is word problems. So now we have to take what we've learned about equations and we have to make the equation. Then we'll have to solve the equation. So a couple aspects, some things I want to try to show you to help you along in that process. But what we've got to do is take the words, turn it into an equation, and then go ahead and solve the equation. All right, so the first thing is something I've been telling you to do, and that is to NTV, which is name the variable. So you want to start off by naming the variable. Now, I told you this last time, I want to keep reminding you. In some of the easier ones that we're doing, and because this is pre-algebra, we are doing some of the easier ones. It doesn't seem like a big deal to name the variable because it would be very obvious. However, the further we go along in our math, the more important it becomes to name that variable. So it's something you should get used to every time. It's something you should have in your homework every time. If you're doing a quiz problem or test problem, you should start off with naming the variable. It's a habit you should get into so that then when you have those more complex ones, you're off on the right foot and able to solve them. Okay, so name the variable. The word is the, somebody raise your hand and tell me if you know what goes in those blanks. Nia? The equal sign. So the word is the equal sign. All right, use blank words to write the relationships. Anybody know what goes in that blank? Use blank words to write the relationships. Help you out, it begins with an O. Let's hang, the hangman. All right, Colby, give me a letter. You know what? There's way too many. Anybody know it yet? Raph? No. The next letter is P, though. Anybody know it yet? Yes, sir? Nope. E is the next one. Christina?
Operation.
It is operational. Use operational words to write the relationships. Somebody tell me give me an example of a mathematical operation. Somebody raise your hand, give me an example. Christina? Addition is an operation, right? Subtraction, multiplication, division, etc. All right, and then solve, and I should have a comma there. Solve, comma, then ask demands. Again, we're doing a word problem, and we should get used to, anytime we're doing a word problem, to ask demands, does my answer make sense? But look, beyond this, we're going to do some examples. Now here's the thing with word problems. I will never give you a word problem on a test or quiz that we've already done. Because these aren't things that you memorize. You can't. They're real life situations. So we have to learn principles over certain word problems so that we can do other word problems. But the idea here isn't to memorize a word problem. It's to learn the process so we can convert any word problem into an equation and then solve that equation. So it's the process that we're trying to learn, so see if you can focus in, pay attention, and ask questions where you're not sure what's going on. All right, so we'll start off pretty simplistic. The sum of a number and 7 is half the number. The sum of a number and 7 is half the number. Well, we have to start off with a variable, and it's your choice. I like n. And in this case, n is simply the number. Now, it's not a whole lot to that, but it does get us going. When I do mine, I like to stick the equal sign in. So hopefully you agree that word is right there is the equal to. The sum of a number and 7 is, or is equal to, half the number. So we got an equal sign there. Now we got stuff we have to deal with on the left and stuff we have to deal with on the right of that equal sign. All right, so you're looking for operational words. So can anybody give me an operational word? Emily? Sum. And what do you want to do with sum, Emily? I would definitely add, right? Sum means to add. Okay. So What are we going to add on the left-hand side? What are we adding? We're adding two things. What are we adding? Allison? So tell me what to write. You want me to write?
No.
The number?
N.
All right, there we go, right? Because we named the variable, the number is n, so we're going to do n plus 7. Would it be okay if somebody else wrote 7 plus n? Would that be okay? Would that be okay?
Yeah.
Some are saying yes. Somebody raise your hand and tell me why yes is okay to say 7 plus n. Daniel? Commutative property, right? It says if two things are added, you can change the order. So that could be n plus 7 or 7 plus n. Either way is fine, not a problem. All right, that's the left side. How are we going to say half the number? And there's really two different ways we can say half the number. Anybody have any idea how to say half the number? Half the number. Nia? N over 2. Does anybody agree that n over 2 would be half the number? Let me help your thinking. Just pause for a second. Got to get you to think. Let's suppose we had a number, and the number is 30. Doing what Nia said, would that give us half the number? Does it? Let's see if it works for something else. Let's suppose the number was 24. If doing what Nia said, n divided by 2, does 24 divided by 2 give us half the number? It does, and that is one of the ways to take care of it. So the number is n, and to get half of it, we have to divide it by 2. So n over 2. That's half the number. There's one other way to do half a number. So that's divide it by way. There's actually a multiplication way to get half of a number. If I had 10, what can I multiply times 10 to get half of it? Colby?
5.
Decimal is one way. Instead of 0.5, let's use the fraction that equals 0.5. What would that be? 1/2. So you can either divide by 2 or multiply by a half. So this is either going to be divided by 2. I prefer divided by 2, but I will put off to the side, or you could have said 1/2 n. Either way will work. They're the same thing. N divided by 2 and 1/2 n is the exact same thing. You might say, Mr. Scarfi, I wouldn't have known to do n divided by 2. Well, I know. That's why I'm doing it as an example, right? To show it to you. So if you had 1/3 the number, what would you do?
26.
What would you do? 1/3 the number. If half the number is n divided by 2, 1/3 the number is n divided by 3, right? Et cetera, and that's how you take care of it. You could also do 1/3 n if it was 1/3 the number. Okay, now we have to solve the equation. Well, now we have to get all our variables on one side. Okay, in this format, the best way to look at this is 1/2 n. So how would I move the 1/2 n from the right to the left? Somebody tell me what to do. I want to move the 1/2 n from the right side to the left side. Chloe? Okay, so I'm going to add a negative ½ n to both sides, right? I like to put it with the variable. I'm going to add a negative ½ n to the left, and I'm going to add a negative ½ n to the right. Now again, fractions tend to get students a little crazy. So let me get you to think, all right? We got to think. Don't write this. Let's suppose if on the left-hand side we had something like this. 7x minus 11x. What do you get when you do 7x minus 11x? Colby? How many agree with them it's negative 4x? Okay. We've done that. We can all do that. The point was we add the coefficients, right? 7 minus 11 is a negative 4 of the x's. We have negative 4x. Well, that's exactly what we have to do in this situation right here. How many n's do we have on the front? An n is how many n's? Somebody raise your hand. An n is how many n's? Amber? 1. So I'm going to stick the 1 there. So what do you get when you have a positive 1 and a negative half? What do you get? Allison? You do get 1/2. If you can't do that, then you're going to have to do it like a fraction and do 2 minus 2 minus 1/2. But the answer is, whoops, that shouldn't, well, we'll leave it in green, 1/2 n. What do we get on the right? What's a half n minus a half n? And I hope you think it's 0, right? We had a half of them, we took away half of them, we got nothing left, we got 0. Okay, so how do we finish off this problem? Let's add a -7 to both sides. And I'm going to come off to the right here because I'm out of room. So my left-hand side is 1/2 n, and my right-hand side is -7. Do you agree with that? Okay, so how do I finally isolate the variable? Somebody tell me what to do next to finish this off. Ashley? So what do you want to multiply by? I agree. Multiply the left by 2/1. Multiply the right by 2/1. I'll just put a denominator there to make things clear. Are you on strike, Kristen? All right, so the right is -14, and that's our answer. The sum of a number and 7 equals half the number. Let's see if that works. What's -14 plus 7? -7. What's -14 divided by 2? -7. Ah, it worked. Okay. Does my answer make sense? A lot of times that's what you're going to have to do to figure it out. You're going to have to sub it back into the original and see if indeed you get a true answer. All right, so sum of half the number and 7, or sum of the number and 7 equals half the number. Let's try another one. Again, everyone's a little different, so we've got to learn some principles and see if we can figure out how to do these. Let me go higher for you guys. Come on. All right, so B. Twice the sum of a number and 2 is 8 less than the opposite of a number. Okay, let's name the variable. The number. And so, again, you're going to use a variable. I like n. You can use x. You can use t. You can use v. You can use a. You can use b. Just avoid o, because o looks like a 0. I would avoid l, because that could look like a 1. All right, so we'll name the variable. We'll call the number n. Okay, you find the equal sign? Hayden, where's my equal sign?
Between 2 and 8.
Okay, so that word is right there is my equal sign. And that does divide the left side from the right side. So let's work on the right side first. There's a couple operational words now on the, the left-hand side. Let's work on the left-hand side. I see a couple operational words. So what are one of those operational words? One of those. Come on, you guys need to be thinking. Raph? Sum. All right, and sum we dealt with a minute ago. That's a plus sign, right? So what two things are we adding for the sum? What two things are we adding for the sum? Hannah? I agree. Hopefully you do as well. N plus 2. Right? The sum of a number, so the n is a number, and 2, so n plus 2. Now there's one other operational word on the left-hand side. Amber? No, that's on the right. We're working on the left. Juliana? Twice. Twice what? The sum of a number and 2. So how are we going to do this one? You got to be careful here. How are we going to do this one? Nia? Okay, so you said n plus 2 in parentheses and 2 on the outside, like that? How many agree with Nia? That's exactly what you have to do. A lot of students will only stick the 2 in front of the n. If the 2's only in front of the n, isn't it only doubling the n? But what do we need? We need twice the number n2. That's why the number n2 has to go into parentheses. Now that's tricky, but you have to be careful because at times a parentheses is necessary. You got to have it. If you don't have it there, we're not going to get it correct. So that is correct. 2 times the quantity n plus 2. All right, that's the left side. Now we got to do the right side. So again, you're looking for operational words. And what kind of operational word do we have on the right side? Colby? Okay, and what are you going to use for a less than? I agree, that's a subtraction. And now we have to know, and remember guys, we did problems like this earlier with just this part. For addition, does it matter where the numbers go? Does 5 plus 3 equal 3 plus 5? Does it matter in subtraction? Does 3 minus 5 equal 5 minus 3? No. So it matters. So we got to make sure we get the 8 in the right place and the opposite, the number, in the right place. All right. Who wants to tell me where to put the 8? In the front or in the back? Let's take a vote. So you're going to say front or back on the count of 3. All right? Here we go. 1, 2, 3. It is the back. The 8's got to go in the back. How do you make something 8 less? You do minus 8, right? It's going to make it 8 less. Okay. We got one more thing to deal with. How in the world do we say opposite the number? Christina?
8 minus n.
8 minus n? Not quite. Opposite the number. Hannah? It is negative n, right? If the number's n, opposite the number is negative n. All right, so there's the equation. Now we got to solve it. All right, we're going to distribute first. Do you agree? 2 times n is 2n. 2 times 2 is 4. And we still have a negative n minus 8 on the other side. Okay, so class, whenever you see variables on both sides, once you've done all your distributing and adding the like terms, you got to either move the 2n from the left to the right or the negative n from the right to the left. My choice, again, is always to get it positive. That means move the negative n. So, Nathan, how do I move the negative n from the right to the left? Add what? I agree. We're going to add n to the right. And whatever we do to the right, we got to do the same thing to the left. Okay, now we have 3n plus 4 equals negative 8. Now it's down to, let's move things, add it to the variable first. Let's add a negative 4 to both sides. Now we have 3n equals 8 negatives and 4 more negatives is 12 negatives. And now we can do the shortcut, divide both sides by 3. And this answer is n equals negative 4. Does that work? Negative 4 plus 2 is a 2. I'm sorry, is a negative 2. Negative 2 times 2 is a negative 4. The left-hand side is negative 4. A negative 4 is a positive 4. Positive 4 minus 8 is a negative 4. It worked. Right. But again, with word problems, that's how you're going to ask, does my answer make sense? You're going to go back in and you're going to try it. Okay, C, 3 less than 4 times a number is 6 more than the number. Let's name the variable. And again, in this case, it's the number, and we're going to use n. I'm going to pause the video. I want you to try to write the equation and solve it. So you should end up with 4n minus 3 equals 6 plus n. Again, subtraction matters that it's 4n minus 3. 4 times the number is 4n. 3 less is minus 3. 6 more than the number, either 6 plus n or n plus 6, either way on that one. Any questions on that, anybody? Any questions on that? Okay, let me show you a couple special cases. Consecutive numbers. Sometimes they'll say something like 2 consecutive numbers, 3 consecutive numbers, etc. Okay. Let's suppose the first number is n. By the way, consecutive numbers are like 11, 12, 13, 14, 15, 37, 38, 39. Negative 9, negative 8, negative 7 would be consecutive numbers. Okay? So, if the first number's n, what's the second number? What's the second number? And if you say y, then we won't be able to solve the problem. So we don't want to say y. So let me help you out. We'll figure this out. I'm going to give you a number. You tell me the next consecutive number. Okay? You ready? 7. You guys are brainiacs. You're just amazing. All right, here we go. 39. Wow, you guys are so smart. You're able to give me that next number just like that. Here's a tough one. Negative 15. 14. Negative 14. Okay. So, you ready? N. Okay, I didn't hear the answer, so quiet, please. Let's try again. Think about what you're doing, okay? Think about what's actually happening, because you're just mindlessly saying the answer, but think about what's happening. 51. Okay, think about what's happening, all right? Ready? Let's try another one. 73. 74. Think about what's happening, all right? So let's try again. N. I heard the answer that time. Somebody had it over here. I heard N. Nope, not 2N. N plus 1 is the answer. The next number is always N plus 1. Hey, when I said 11 and you said 12, isn't 12 11 plus 1? When I said 73 and you said 74, wasn't 74 73 plus 1? Yeah, it was. Okay, now let's get to the third number. So again, I'm going to give you the first two. I'm going to give you the first number. Give me the second and the third. All right? 10. Okay. 51. 53. Okay. So pause for a second. If I say n, the next number is n plus 1, and the next one after that is? N plus 2. Awesome. N plus 2. That is correct. Consecutive numbers are always, the first one's always n, the second's always n plus 1, the third's always n plus 2. If we had a fourth, it would be n plus 3, and the next would be n plus 4, etc., etc. Always. That is always the case for consecutive numbers. Now, what if they ask you for consecutive even numbers? Well, we're going to start the same way with n. And just to make sure we're thinking right, I'm going to give you an even number. You give me the next consecutive even number. 8. 10. Great, you guys are just brainiacs. 76. 78. Okay, now again, think about what you're doing to get that next number. 108. 110. Okay, n. N plus 2 is the next consecutive even number, right? I don't remember the numbers I did, but if I said 12, you'd say 14, because 12 plus 2 is 14, right? Okay, so again, let's get to the third number, all right? 6, 8, 10, right? 22. 24, 26. N plus 2. N plus 4. And every time you have consecutive even numbers, that's the case. Every time. All right, now this blows students' minds, but it's not a big deal. Let's do consecutive odd numbers. So again, let me give you a number. You give me the next consecutive odd number. 7. 9. Okay. 13. 15. N. n plus 1. So 13 plus 1 is 15.
N plus 2.
If I say 13, you're going to say,
15.
how do you get from 13 to 15? It's n plus 2. Did your teacher somewhere, I don't know, is this first grade, second class, we're going to count by twos. Ooh. 2, 4, 6, 8, 10, and you went through. Class, we're going to count by twos. 1, 3, 5, 7, 9. Either way, you're counting by twos. One is you're starting with an even number, and the other is you're starting with an odd number. So therefore, the first number is n, the second still n plus 2, and the third is still n plus 4. So whether it's consecutive odd or consecutive even, it's n plus 2, n plus 4. Christina.
Consecutive.
Right after the other. So 1, 2, 3, 4, 5. But if they say count by even numbers, 2, 4, 6, 8, what's the next even number after 8? 10. What's the next even number after 10? 12. What's the next even number after 12? 14. Same with odd. After 7, what's the next odd number? 9. After 9, what's the next odd number? 11. So it means right after it. Okay, so one last problem here. The sum of two consecutive odd numbers is 84. Find the numbers. How do we start? With NTV, guys. It's the only TV we want you to watch, NTV. Okay, and we have the first number and we have the second number. Do you concur? So the first number we're going to call n. And the second number we're going to call n plus 2. It's consecutive odd numbers. Not consecutive. If it said just consecutive numbers, it'd be n plus 1. But remember, for odd numbers, you're counting by twos. For even numbers, you're counting by twos. It's by the 2. Okay. The is the equal. Do you agree? Omar, you've been real quiet today. What do I put to the right-hand side of the equal sign? Right is this way. 84. Do you concur? You should concur. And the left, the only operational word is sum, right? So I know I need a plus sign. Somebody tell me what to put on the left and right of the plus sign. What goes on the left and right of the plus sign? Left and right. Raf? N and n plus 2, right? I added the two consecutive odd numbers, right? So the sum of two consecutive odd numbers is 84. Let's see how this all works out. So let's add like terms. 2n plus 2 equals 84. Let's move things added to the variable first by adding their opposite. So you get 2n equals 82. Let's multiply by the reciprocal, or let's do the shortcut. Let's divide by that 2. 82 divided by 2 is 41. What is 41? No, what is it in what we're trying to find? 41, look, this is why we named the variable. 41 is the first number. What's the second number?
43.
The second number is 43. Make sure you finish off by answering the question. You say, how did you get to 43? Because the second number is n, 41 plus 2 more. 41 and 2 is 43. Christina. Say it again.
Could you, instead of saying n plus 2, could you say n plus 2?
No, because n plus 2 is not 2n plus 2. Well, here's what you got. This is one n, and this is one n. One of them and one more of them is two of them. Right? We had to add up our like terms and got 2n plus 2. All right, so guys, listen now. Each one's a little different. I tried to show you some tips to help you. Now you've got to go ahead and do that as you work through some of these problems. The only way you can get good is if you try them yourself. Okay? So try your best. If it's an odd, you're going to end up looking at it. Once you look at it, think about why it is what it is. Make sure on your homework paper I'm seeing you name the variable. Make sure you're showing me your equation and then you're solving it, okay? All right, off you go.